Afzal sir. Have you received? Archana madam?
Yes, sir.
You received the MCQs?
MCQ.
I forwarded to your email.
Okay, sir.
Afzal sir, tomorrow last session.
Okay, sir.
Yes, Ramesh also joined. Hi, Ramesh.
Hi, Gopi.
Yeah, your friend already came.
Hi, Ramesh. Both are Ramesh.
Mama. Hi.
Exactly 6 people are joining. They don't want to waste time.
We'll start the program, sir.
Just 1 minute, madam. Just
I
people
think
are
we can wait
joining.
for a couple of minutes, Gopi. Only 27 are there, I think. We'll wait for a couple of minutes.
Just a few minutes, madam. Surilin madam just joined and left, I think.
Yes, sir.
I think we can start, madam.
Okay, sir.
Ramesh,
Good evening, everyone.
start.
It is my distinct pleasure to welcome you all to this evening session on the fifth day of our ATAL FDP. We have covered a remarkable amount of ground this week, but we have saved a truly essential and forward-looking topic for today. Today, we are honored to have a distinguished expert join us, Mr. M. Ramesh, sir. Mr. M. Ramesh is the Chief Engineer at MMN Dastur, a company well known for its innovative approach and commitment to engineering excellence. With his extensive experience and leadership in the field, he brings a wealth of practical knowledge that is highly relevant to our current challenges and future goals in the construction sector. Mr. Ramesh's presentation today is on a topic that sits at the very intersection of efficiency and responsibility, interchanging project management practices in next generation sustainable construction. As the construction industry involves the imperative to build not just effectively but also sustainably is stronger than ever. This session promises to explore how BROST project management is not just about deadlines and budgets, but is a crucial tool for ensuring our projects meet the highest standards of environmental stewardship and resources efficiency and long-term visibility. I know we are all eager to hear these insights on translating sustainable vision into managed, successful, and reproducible projects. Please join me in extending a very warm welcome to Mr. M. Ramesh, sir. We look forward to your valuable expertise. Please, sir, the floor is yours, sir.
Yeah, thank you, madam.
Yes, sir.
Good evening to Dr. Gopinath, Director MITS, and Professor Ramanujan Naik, Dr. Cyriline Raut, Civil Department MITS, Archana Madam and Shivani Madam who are coordinating this program, and all other faculty members attending the seminar. It's a very nice initiative by AITC where the domain experts are asked to present their experiences and their views on various aspects of engineering fields. So I would like to thank Gopinath again because I was novice to these type of presentations. I never go out of, we present only to our staff and our higher ups. So presenting to academicians is my first.
Most welcome, sir. Most welcome, Ramesh.
Thank you, thank you, thank you. And about myself, I am a civil engineering graduate from Geetam University. I passed out in 1989. I am a gold medalist from our college. And I have an experience of 36 years in the field of project management. Our company, MN Dastur and Company, is a renowned consultancy organization, having constructed various steel plants all over the world. And we are providing consultancy services. We are already expanded into consulting services in the energy sector as well as power sector. Presently, I am working as site in charge at Visakhapatnam Steel Plant site. We have been executed the projects worth about 20,000 crores in Vizag Steel Plant in past decade or so. So these include setting up of a greenfield steel plant of 2.8 million ton capacity, which has all facilities of steel plant like raw material handling plant, sinter plant, blast furnace, steel mill shop, and associated rolling mills and finished product sorting and dispatch yards. In addition to that, we have to also executed the infrastructure facilities like power systems and all the outdoor pipelines, outdoor transmission systems for the evacuation of power, etc. And about myself, I joined Dastur in '89 at Vizag Steel Plant site. From there, after finishing this project, I moved on to other site like Rourkela Steel Plant. Then I went outside to Trinidad for monitoring activities of Kareem Ispat Limited belonging to ArcelorMittal. Then I worked at Tata Steel, and we had a power plant at Naval Lignite Corporation where we were the project maintenance consultant for 2 into 210 megawatt power plant. Now, in addition to the greenfield expansions, we also do the brownfield expansion. Like the Vizag Steel Plant was built in 1990s, the first phase. So now the most of the facilities become obsolete, or rather they have lived their life. So we also revamped all the phase 1 facilities like blast furnace, central plant, steel mill shop, etc. And our company is very much involved. We are the principal consultant for the whole of Vizag Steel Plant since inception. So about after introducing myself, today's presentation is basically about integrating project management practices in next generation sustainable construction. So first of all, the presentation will be in 2 parts, and I will briefly talk about basics of project management, and then we will discuss about the main topic, that is next generation sustainable construction practices. The concept of green building construction is very novice in India, particularly in residential building constructions. In industrial area, to some extent, the clients are insisting on green constructions where they want to use the innovative or environmental materials or renewable energy installations like solar roof or solar roof panels for the generation of power and etc. And they also have the vast areas of land available for installation of these solar power plants. But when it comes to residential constructions building, we normally look at the cost of the construction. We'll try to save each rupee or penny on this construction methodologies. However, if you spend a little extra on these innovative or environmental friendly or concepts where it may cost little extra, but the savings when we use these facilities like over a period of few years or few decades, the savings will be enormous. For example, when we remember, we used to pay unit power for 1 rupee or 1.5 rupee about a decade back. Now we have to pay about 6 to 7 rupees per unit. Had there been facilities were installed, maybe that time it was very novice, or it was very, people are not aware. And of late, if you are able to install these facilities at a little bit extra cost, this will have substantial savings on our pocket, as well as it will have a very good environmental, it will reduce the carbon footprints for the environment. Now, in the recent, all the presentation, I was participating partly in the various resource person presentation. Most of the people are discussing about the environmentally friendly materials, but however, the practice or application of these things are very limited in nature. Probably one factor is that maybe economics of the adopting those things. To some extent, where it was explained last resource school, Ramesh was telling that there is a lot of cost savings if you adopt these innovations. But however, when it comes to residential buildings, there is no such a stringent code, or government is not very much keen on, like when they're approving a plan, they should have basic checklist where each residential building should have these facilities. Now, but in recent times, they are insisting on for apartments to have rainwater pits or solar roof panels for generation of electricity, etc. But now there are a lot of education, there are a lot of awareness need to be brought into the people, and government also need to support, or they have incentivized some of the facilities. They can give some subsidy or some discount on the taxes, etc. Now let us go into presentation. Now I'm just sharing my presentation. Yeah, hope it is visible, Gopi.
Yes,
Yes, sir.
visible, visible. First
Yeah.
slide. Okay.
Yeah, this is the first slide. And as I said, this will be in two parts. I'll discuss about basics of project management, and then we'll go to the second part. We'll discuss on the integration of project management practices and sustainable construction. So what is a project? It's unique in the sense, even though if you build two identical buildings side by side, they are unique in the sense the coordinates will be different. So that way, each project is unique and it is a one-time endeavor. And it has got a specific start date, a specific end date, and a defined scope with a strict budget. And projects are performed people who have limited experience in working together as a team. What I mean say, they will be having different teams working, like construction people will be positioned at site, and procurement teams will be positioned at the client, and engineering teams will be positioned at the design office. So all these people have to work together to successfully complete the project. So it becomes a teamwork, much of a teamwork than the individual contributions. The project management is basically application of your knowledge. That's what you have learned by reading or studying or by experiencing, by imparting various education, training, etc. And then the application of those knowledge and using the tools. The tools basically project management tools like software, like Primavera or MS Project. Then to apply these tools to the techniques, techniques in the sense we have different types of techniques are there, where you have, if it is small project, you may be having, it will be sufficient to have a small bar chart. And if it is a complex project, you need to have a detailed network interconnecting all the activities and to meet the project requirements. As I said, project person will work from different locations. These constraints often make project management difficult and complex process. So nowadays, the technology is so advanced that each people can access their part of the schedule and update. And one person will be sitting in the say head office, where he will review all the updates and he will schedule the project to see where we stand as on date. This is the project management goal. We call project management golden triangle. The three aspects of project management are: one is the scope. You should have a definite scope for a project, and you'd have a definite timeline to complete the project, and it will have an associated cost, which we normally try to adhere to the cost at unless there is any change in the scope. And all these things will have a quality aspect. So you have to do the work in a qualitative manner, and you have to finish the project with acceptable qualities. Like when the stakeholder takes over the project, he should be able to use it perfectly for what the purpose it is intended for. The basic steps of project management are: first is the planning. The second one is scheduling. The third one is controlling, and the fourth one is closing. This earlier, the closing was not given so much importance. So in the previous slide, if you see, the closing aspects are not much discussed, but it becomes very prime important for any project to finish the closing activities, which I'll explain in the coming slides. Planning, like it's the most important phase of the project management. It involves defining your what is your objective of having a project, and list out all the activities that are needed to complete the project, and what are all the resources required for meeting those activities, and prepare cost estimates, and also the timeline. Time means is a duration for each activities. So the activity should be sufficiently defined. Like you should not have a very broad activities which spans over a period of few months. If it is so, then you don't have much of a control on the activities that are very much longer in period. So you need to break down sufficiently so that it can be managed or it can be monitored properly. And activities are those operations of the plant where we spend time to carry out and on which the resources are spent. Then once your plan is ready, then you will go to the next phase, scheduling. The scheduling basically it's integration of all the activities you have planned, assigning the durations, resources. Earlier phase you have just defined the resources and what resource you need, and then in this phase you will assign the resources and the sequencing of the activity, which comes first, which comes second, which can be done in parallel, which can be done in independent, and which need to be done in a sequential way. All those things will be defined in this scheduling phase. And once you interlink all the activities, you will be calling that schedule as baseline schedule. In the baseline schedule, normally your target date will be matching with your project requirement. And this planning and scheduling phases are undertaken before you actually start the project. So you have to be thoroughly, you have to probably do a couple of iterations where you may be exceeding your budget, or you may be exceeding your timelines, or both. You may be exceeding both timeline and time schedules and budget aspects. Then you need to go back and check where you can cut down on the prior cost or cut down on the durations. And then after a couple of iterations, you will be able to come out with a plan which within your budget as well as within your required timelines. Then this controlling phase. Once the project is undertaken, the project activities start progressing. Then there will be like normally we use software like Primavera, Microsoft project for bigger projects. For example, in case of our Vizag steel plant, we have about 7,000 activities approximately for the monitoring of this 2.8 million ton steel plant. It has got about 16 zones and various activities in that. So if you have a software or to monitor the project, your life becomes easier. Those type of complex projects cannot be monitored using bar chart or your arrow diagram networks. So basically, we used Microsoft project also, and mostly in Primavera. And Microsoft project also can be used for planning purposes. In the sense it is very easy to use and can be used for smaller projects. But we preferred Primavera because it has got very good scheduling capabilities or interlinking capabilities with activities, then scheduling, monitoring, and it has got a facility for adding resources, and you can schedule it at a regular intervals to arrive at what is your progress of project with respect to the cost you have spent on that. Then after you run all the schedules and update the project, now you have a updated plan, which you have to check whether it is meeting your end date or not. If the end date is not meeting, then you have to go back and see which activities are delaying this project, and how to bring back those delayed activities on the schedule. It will be discussed in various forums, and they will try to draw up some mitigation plan, which may need a little bit of extra resources, or maybe you need to reschedule. You may reschedule the project so that some activities can be taken up in parallel, and you may be required to add another agencies or contractors to speed up the process. Those decisions will involve cost implications. But when it comes to saving a few days or few months in a project, there is a judicial decision by the management where they will take a call, whether if you spend extra resources or delay project by a couple of days or a couple of weeks, etc. And then after everything is done, we'll be reporting the outcome of these controlling process to management in the form of MIS report. MIS basically management information system reporting. So once the reporting aspect is done, that will be reviewed by various levels of the management, then they'll act on those reports. And the last phase of the project is closing. The closing phase is very, very important in the sense, unless you complete and close the project and get out of the place, it becomes, it's like it will be pending your project list for a very long time. Once project is commissioned, like the client has accepted or the project has performed. For example, in case of a blast furnace project, the performance will be completed when it produces 66% of the rated capacity. Say about if it is rated capacity 6,000, say about when it produces 60%, 6 into 6, say about 4,000 tons when it produces, it says okay, project is achieved its required goals and the project can be taken over. Once the contract project is taken over the client, everybody get relaxed. So the whole in case of our practical experience, what we are facing here is that they have a good amount of payment by the time the project is taken. Say about 85% of the payment is given to the contractors once it is commissioned. So then comes the other activities like handing over of the site or handing over of preparation of as-built drawings or preparation of your final builds. All this gets as backbench. And also they have to prepare all what are the lessons you have learned and what you actually built. Is like preparing as-built schedule as well as as-built document. In the initially, when you prepare a project, you have a detailed project report. That project reports may undergo a little bit of changes during execution, and all those things need to be documented. And at the end of your project, you have to hand over all those documents to the client and take a completion certificate. Then only there will be some bank guarantees given to the client to safeguard their client interest and also to complete all these activities. Unless you finish these complete activities, your bank guarantees will not be released. So in many cases, that gets stuck for years together, even after completion of the project. So this is the first phase of the project, first phase of my presentation. Then we go to the next part of the presentation, integrating project management practices in next generation sustainable construction. Okay. The important sustainable construction in the construction is basically we have to safeguard our environment. That is the concept of this sustainability. In the worldwide, the construction sector, including life cycle usage, life cycle is in the sense once you construct a building, you will be occupying the building and you will be using the building for maybe a few decades. That is called life cycle usage. It is responsible for about 40% of global carbon emissions. This figure is very much astonishing because now we are in a very novel stage of this environment sustainability construction. If you see the carbon footprints, okay. Yeah, construction industry, I said 40% of the carbon footprint is generated from the construction sector. But the carbon, you must be aware what is the carbon footprint. It's basically all the sum of the expressed in terms of tons, all the greenhouse gases generated by a entity. So for example, it will be carbon dioxide. Then you have carbon monoxide, methane, nitrous oxide, hydrofluorocarbons, etc. So out of this 40%, the 10% is about is coming out from the construction activity. That is the building up to the building stage. Then the next 30% comes from the building life cycle or building operations, like the energy they use and the waste they generate. And the waste they generate also the the habitats, consumption habits. And then about 15% of this carbon footprint is generated from the transportation industry, and agriculture industry consists of about 14%. The rest belongs to other industries. And also the construction sector is one of the largest generator of waste worldwide. In a figure which probably these are all are rough estimates available on the internet. So India generates about 150 to 170 million tons per year, and primarily because we are moving very rapidly into the cities for due to urbanization. And a small country like England generates about 63 million tons annually. So in general, about 30 to 40% on an average, the construction industry generates waste out of the total waste that is being generated. In construction, normally we have waste from the concrete, like this also includes the rebuilding aspect or dismantling of a building and then reconstructing the building in the same place. So basically the various components that are consisting of waste, where this construction waste is the demolition concrete and bricks from the demolished walls, wood, metals, glass windows, asphalt, plastics, and gypsum from false ceilings, and then insulation material which used for the purpose of insulation. So then, so this is a very huge figures that need to be tackled in future. Actually, there is no regulatory compliances. There is no mandated regulatory compliances for this green emission to prevent environmental degradation or use of environment-friendly materials in any part of the world. But the World Green Building Council is a body which consists of various. Every country is now trying to take care of all these environmental related sustainability policies. So now the Green Building Council has put up resolutions. By 2030, all new constructions and renovations will have at least 40% less embodied carbon. This embodied carbon basically when you use the materials, all materials including steel, cement, insulation, your energy, piping, and all plastics. And all new buildings must be net zero operational carbon. That means when you are occupying the building and using it, the carbon emissions must be zero. And by 2050, all new constructions and renovations will have net zero embodied carbon as well as net operational carbon. But these targets are only voluntary on the part of the various governments. But now probably in coming years we may see some regulations where it may mandate a certain amount of laws and regulations to control this phenomenon. So what is sustainability in project management? So it involves incorporation of various environment. We have to incorporate all various environmental aspects, social and economic factors throughout the project lifecycle, not only in the design stage, as well as during execution of the project as well. Like we have small these environmental factors already in place, where if you want to build a factory or an industry, they have to conduct environmental feasibility studies. That means how the industry is going to affect the environment around that place. Like it may the pollution relocation of the residential buildings at present in those areas. Then they have to also study what are the pollutants that are generated by that industry, and how the people are likely to be affected, etc. When the steel plant of Vizag steel plant was made, that time about almost 25,000 hectares of land was acquired, where villages by villages are asked to vacate. And this has impacted many, probably a few lakhs people got affected. But however, the government has made arrangements for rehabilitation of those people in the nearby areas. Then they procured the land and gave the habitation facility. Habitats in the sense they provide the roads, infrastructure, and all the necessary social amenities for those people. So now the next comes the economic factors and the social economic factors. See, this is basically how the people get affected in those areas, and then how the economic activities will improve or deteriorate. So all those things have to be studied well in advance and in detail, and those needs to be incorporated in our sustainable project management practices. Next, the key strategies, including setting clear, you have to have a clear set goals, like what we discussed in the previous slide. By such and such a year, you have to have such a percentage of carbon, environment friendly materials, and zero carbon emissions, etc. And you need to have facilities for keep in mind the renewable energies, how we can utilize the surrounding environmental factors, like places where you have sufficient sunlight. You may have to use the solar panels to light up your say corridors, or maybe in the roof lighting, etc. And you have to use the construction techniques such that you will be able to minimize the waste. Like minimize the waste in the sense, you may have to in maybe coming years, you will be having a facilities to prefabricate the walls or the slab, roof, etc. at a factory. These things are already in place for the industrial areas, like construction of bridges or construction of warehouse, etc. But in residential, in the residential part of the construction, those things are not yet become popular. And you can have to use the smart technology like BIM means building information modeling, where you will be able to see how far you have built the project and how far your progress is there with respect to your money you're spending. And probably by using building information model, you'll be able to improve the performance where you're lagging behind and how to bring back into the schedule. So it's only project management, sustainability in project management, not merely a trend. In the sense, it's just not like any academic subject or things like that, but it needs to be addressed seriously to take care of our environment. So then. Next point, incorporate sustainable principles enables project managers to contribute meaningfully to the environmental preservation, social well-being. And so by adopting all those practices, the planning managers or the people who are planning or executing or monitoring the project will be able to effectively implement the policies or processes that are good for our environment. So the basic principles of sustainable construction, there are 7 principles broadly listed. However, these need not be these are not like a Bible. You can have some more processes or some more stages where you can add, delete, or merge together, so that you have a depending on, probably this may vary based on your project which you are building. Maybe this get a little bit modified for a residential building, or it may get modified for industrial building. These are broad guidelines where you can divide your various stages of the process of sustainable project management plan. The first step is that sustainable design. The sustainable design aspects, this needs to take care when you are designing, when you are planning a project. You have to consider all the present available technologies to save our carbon to reduce the carbon footprint, and various energy efficient green materials available, energy efficient technologies to reduce the carbon footprint. And also you have to adopt a design, or you have to once you make a plan or a design, there are certain agencies available, like there are like third-party agencies which check your plans or your designs with respect to the certain guidelines. Like the agency, one agency is that BREEAM. Is basically a building research establishment environmental assessment method. Is the world leading sustainability certificate system of our buildings. They will have some guidelines. Okay, here when you are making a building, so you should have these facilities. Like you should have a 10% of your roof to be covered, or 150% roof to be covered with solar panels, or you may have one rainwater collection pit, or you have a rainwater collection recycling facility. All those things will be defined in a systematic manner. So once you get these certification from third-party agencies, you will be at least satisfied with what you have done. And maybe in future, government may ask for the certification from third-party agencies. Like when we go construct a plant, when somebody manufactures an equipment, then our company will go for inspection, and client person along with consultant will go for inspection, so that the material that have been intended for the installation of the project are meeting the requirements. Similar to that, there will be third-party agency here also. Just now it is in India. Just now we have started these certifications in the multi-story commercial residential buildings, mostly in metro cities. We'll come to that in the end of this presentation. I'll show a few buildings where these type of technologies are being used and also get certified by the various regulatory agencies. The durability. When it comes to the aspect of durability, so you may be using materials and techniques which are available at present. It may be a little costly, expensive, but in the long run, as I said earlier, these materials are durable in the sense if you use good quality paint outside, for example. So you need not renovate or repaint it for maybe 5, 8 years, 10 years, 12 years down the line. Or if you use a material paint that is available in your local market, maybe after a couple of years get faded out, and then you may need frequent maintenance or repaintings. And the contractors who are building the residential buildings nowadays, they are trying to cut corners at every place. So there must be some regulations or third-party agencies inspection. Once your plan is approved by the municipality corporation or RERA, whoever it is agency, there is no further monitoring on those. Normally they give the okay. I'm using this material for the concrete, this material for this paint for this construction, or generic in the sense. So those subsequent to the approval of plan during construction, there is a monitoring mechanism whether that fellow using the good quality materials or not. So this is one of the important aspects. Probably some regulation need to be done in this area. Maybe in industrial constructions, we normally design for about though it to be as a consultant, there are codes available for different types of building designs where you have to consider factor safeties because of your soil conditions, your earthquake zones, etc. Still, as a consultant, we normally design a 10% or 15% extra factor of safety, because the construction qualities will not be up to the mark as you expect. So this is not officially declared, but if you see the designs of our Indian consultant versus European consultant, they look, if you feel okay how these people are designing such a light structures, but they assume that they will build as per the quality specified in the drawing or specification. But in India, it is not like that. Still, that problem is there, because we are witnessing in our day-to-day project activities. And then comes the energy efficiency. This refers to the implementing buildings, implementing technologies or facilities or the designs to minimize the energy usage. See, the energy, like what there's a standard saying, the energy you save is twice the energy produced. That means once you save energy, you're able to use that energy, same energy, some other location. That means you're not only saving it, but it is being used at some other location for usage. So the energy producing industry, that's earlier, nowadays we are slowly shifting into renewable energy sources. But in India, I think earlier days, even now also probably 60% is energy is being generated, I mean, power is generated from the fossil fuel based power plants. Then by adopting these energy efficient practices, we will be able to decrease the carbon emissions into the environment, by which our planet will be saved. Some of the aspects now to be considered for energy efficiency are renewable energy systems like your solar roof panels. Maybe some places very rarely you find some small wind turbines in the residential buildings, which power up some part of the requirements. Then your energy efficient technologies to appliances, like using of LED lights, or there is a systems where now it is already implemented in hotels and big office spaces, where it will detect your person's movement, then automatically switch on the light, and if energy movement, if persons are not moving, then automatically shut off the lights and other facilities. And energy efficient materials. Energy efficient in the sense you have to use a high efficient, high quality insulation materials, so that you can minimize the heat loss or the effect of heat on the inside building. And HVA system, heating, ventilation, air conditioning system. Now the various appliances are being given energy ratings. No, it may be expensive in cost, but like you have a 2-star, 3-star, 4-star, and highest rating of it, 5-star is the rating which is being given to air conditioners. So if you buy the highest rated appliances, you will be saving energy, and probably in the long run you will be able to more. Though you are spending a little higher price in the beginning, you will recover your higher cost during the running of the usage of the systems. Considering building envelopes and orientation. This envelope means walls, roof, windows, and floor. The positioning of the windows or the orientation of the building will need to be studied thoroughly and see the direction of the wind. And at the same time, normally we follow certain vastu for construction of house. So our earlier vastu concepts or suggestion provocated by our olden days is that you have a kitchen on the east side, and since those are all they decided based on, to some extent, to save energy and probably to give good ventilation or ventilation facilities to the inmates. Then comes the waste reduction. This basically, when you make an industrial building or residential building or any type of construction, the first, probably in most of our buildings are demolished before we go for a new construction. Maybe in future we may come across construction or designs to such a way that we will just remove the inner walls, or maybe you can remove the Once which are not usable, then you use the same frame to make a new building. Or like using your prefabricated components in the building envelopes like walls, slabs, or you have prefabricated buildings are being made using prefabricated steel structures at the workshop location. Then if you are using workshop location, the efficiency of production will increase and your wastage will reduce, and the quality on the top of your quality of the work components will very good. So because we have robotic machines or factory high speed building machines where you production will be more. So those things will definitely make your erection activities much simpler, and with little modifications side. So it will save a lot of your money, time, and which in turn adds up to your profitability. And now that in the last couple of years back, it was estimated that about 32% of construction materials sent to landfill due to demolition. So the material that is going to landfills are basically from the various debris generated, like your kitchen waste or your maybe from the mines, waste material from the mines or from power plant. Those things are being filled at various different locations where inhabitation is not there. So out of the total material that is generated for landfills, 32% of construction material is sent to landfills. So it's a very huge quantity, and probably we in coming days, probably it may be such a way that somebody will be able to buy your dismantled material so that can be used at repeated. You can use it again at different locations. And globally, the construction industry produces about 1 billion tons of waste. These staggering figure highlight scale of waste we are generating in the building and demolition activities. And this circular one concept is circular flow of materials, which is just propagating into now some of the construction activities, where when you are going to dismantle a building at the end of their life cycle, say about 40 years, 50 years. Now itself they are planning such a way that those material used in the building, at least part of that can be reclaimed and reused when you make a new building. And then comes indoor air quality. So the paramount important of the any building or residential complex is that the inhabitants should be comfortable while using the accommodations or the facilities what they have been designed for. So then people start occupying the material. They should not complain, okay, how this is looking very ugly, or it is not finishing is proper. You have used the paints of very high material having very high volatile matters. So that for a few months or year, they will be feeling that smell of the paint. Those things should be avoided, so that the people will be comfortable in staying those buildings. And by using energy efficient dehumidifiers, or by designing proper plumbing fixtures so that they will not leak. And I find most of the building that is being a residential apartment will have some leaks or somewhere. If you go and observe in real life, they either plumbing fixtures get leaked or your sanitation fixtures get leaked. So there should be some very strict complaints on these quality checks, because once you find a leak, to identify the leak itself is a Herculean task after a building is occupied. So while designing and constructing, you need to be very careful about these systems, because they get embedded in the walls once they are built. And like your high efficient ventilation air conditioning systems that can remove volatile matters or your impurities that are being generated from outside. And nowadays, probably, I think somewhere reading that they are going to install a air conditioning plant itself like industrial. Normally in industrial buildings or industrial factories, they build a cold chill water plant. Then they supply chilled air to the various building facilities so that the cost of facility becomes economical and it will be reliable. Nowadays, that concept is being percolating into the resident buildings also, like your piped gas connections. Those things are very reliable and very safe and available 24/7. So you need not go for any refill cell. Similarly, that these air conditioning systems are where you'll have a small chiller plant, a small cooling tower. Those things are effective in saving the cost as well as you have a 24/7 access to those facilities. Then water conservation. This is one of the key aspects of sustainable planning. So now onwards, or already there are few measures are being implemented to conserve water. Like other aspects, like to reduce water consumption, include fixing efficient plumbing fixtures. Like, what does it mean? You have a flue set with two. You might have noticed there in the flue set there are two taps will be there. One for the when you have a small requirement, and the other one is for the bigger requirement. And also the volumes are, earlier days we used to have very bigger flue set tanks. Now it's getting a little shorter, smaller. And like shower heads. The shower heads here becomes that okay, you may have a very large with very bigger holes, so which drain more water than required. Those fixes can be selected judiciously, like in kitchen. You don't need very high volumes of water in your kitchen to wash the utensils. So there are fixes available nowadays which will deliver very high jet type of water with less consumption. And next, the rainwater harvesting. This is already in place in many of our residential buildings. They will have a small pit over there, and that will all the rooftops collected water will be directed into a pit, where the pit will percolates the water into the soil. And then probably in some of the countries like Saudi Arabia, maybe desert countries, they collect all the water from your sinks and your washrooms. So not wash in the sense of your bath water, etc. And then recycle it, and they use for for your gardening purposes. Like this is called gray water recycling. From your sinks, showers, laundry, or in non-potable applications, such as that will be treated and used in the landscaping for your gardening, watering, or toilet flushings, etc. In industrial areas also, they have two different systems will be there. One is the potable water system, and the other one is the recycled water system. So one potable water system mainly given to where people will be sitting and using those like for kitchen, the canteens, etc. And this industrial water circuit will be used mainly for the purpose of cooling of the machines, etc. And the next is xeriscaping. This is not that much popular now because we have plenty of water available. These are basically selecting the plants which uses very small amounts of water. And then you have a monitoring, you can install a monitoring system where you can check your water consumption on a daily basis or maybe on monthly basis, so that you can optimize on the consumption of water. I think in our I think now few buildings are installing those meters. Each apartment is having their own meter, like one for their washing areas, one for the other users. Say where they will monitor the. There's only to this basic purpose is that to charge the residents about they have a certain amount of fixed quota, and then beyond that they will be charged. So that will also help you in monitoring and reduce the consumptions. Then using of sustainable building materials. Now these are all newly designed materials, stuff conventional material like stone, cement, steel, cement, etc. As our previous resource person were explaining, a lot of new materials are being developed or explored for use to reduce the carbon footprints. Probably you can use the local available stones, gravel, and stone dust, etc. to use in stuff. Maybe stone dust, because some place if you don't have a stone dust around, you will be using sand. Again, sand is coming from the rivers, so which is becoming scarce day by day. You may be using reclaimed steel, bricks, insulation material, etc. Like there are some materials now being propagated like hempcrete or mycelium based insulation. These are basically have a root very dense root structure. There you will feel some material to be used as a, they can be made into panels and used as the insulation material. And modular prefabricated components. That's what earlier we were discussing, those made in the factories, like for residential, this basically for residential purposes, not the industries are already using this concept. They make all the prefabricated component at workshop and then they'll transfer. Like you might have seen the precessed concrete sleepers. The train will be transporting huge numbers of sleepers through train, through wagons for placing onto the railway tracks. So the similar way of similarly, probably maybe in future you may be having facilities to buy, like earlier days we used to have a in situ concrete mixes. Now this in situ concrete mixer concept is almost non-existing. Everybody is going for the these concrete mixers. They are buying, ordering concrete mixer or phone. Just they are coming and giving you the concrete. Maybe this will also pick up. Maybe in future we'll be able to shift from in situ construction to the prefabricated components construction. Use of fly ash bricks, like you have a lot of waste from power plant, which the government is giving incentives for making the bricks, fly ash bricks. These bricks also can be used in the constructions. And then you have advanced aerated concrete bricks blocks, which have a lot of space, air entrapped into that for insulation purposes. And the steel plant generates huge amount of slag while they're making the steel. So those blast furnace slag nowadays, it is a very, very, very hot material. Earlier they used to dump it as a landfill. Most of the cement plants are buying these slag cement, and just they are grinding these materials and using in the mixing in the cement. It is as good as calcined clinkers. So probably they will adjust the ratio of calcined clinkers and the slag to get a proper composition of the cement. And recycled concrete in the sense they can use the dismantled concrete as a material, one of the aggregate for the making a new concrete. So now many in the sense that now it started, new few projects are being planned in different parts of the world to have a carbon neutral. That means the amount of carbon you are consuming is being saved in another area. Like for example, UAE is building a Muscat city where your carbon emissions will be all zero. Carbon footprint will be zero. It will likely to house about 15,000 residents. And the very interesting project being undertaken by Saudi Arabia, they are building a futuristic city, linear city. In the sense, it's a longitudinal city. They will be building two skyscrapers, each 500 meters high and 200 meters wide. It's about 170 kilometers. But still, this very, very probably they are planning to bring by about 2034. I think they have a FIFA World Cup in that year. Saudi Arabia is going to host the World Cup. So once it is made, it will be green building construction where the carbon footprint is zero. And it is estimated that it can house about 90 lakh residents. I don't know who will going to stay there for so many people. How they're going to bring. And now, when for accommodating these people to occupy this building, they are making very huge facilities like recreation facilities, export special economic zones in that surrounding area, so that this itself become once. Probably in coming days, maybe they are thinking of sustaining their economy without oil. So their plan now, they have got good money to invest, so they are trying to come up with all these new initiatives. But it is very, very expensive project. And in India nowadays, the concept of green sustainable building concept is catching up. Maybe everybody is trying to just to say, okay, yes, I have the concept of building of saving energy. Like Suzlon. Suzlon is a company which is specialist in making wind turbines and executing wind turbine projects. Taj also, probably they are to say, okay, I also have one sustainable building where I'm carbon neutral. And these are the few buildings which are not exactly carbon neutral. At least they have implemented certain methodologies where the energy saving is considerable. I just show these buildings. Just an example. Okay. Are you able to see this opened tab? Hello? Hello?
Yes, sir.
Yeah, could you see my open tab?
Yeah, my slide is there, sir, only.
Yeah, that's I'm just going to show these buildings which are made in India, which are close to environmental or carbon neutral.
Okay, sir.
The building which you are showing is a Suzlon 1 office in Pune. You can see small turbines installed on rooftops. They are installed rooftop turbines to save energy. And the next building is Vivanta by Taj. See, it is mostly paneled with glass. Probably they will be able to save a lot of energy, lighting, etc.
Sir,
Then,
but the tab is not visible, sir.
not visible. Okay,
Yes,
okay. One second. Share. Okay, I'll come back to presentation again. Probably I have to share this tab now.
Okay, sir.
What about now?
Yes, sir.
Okay.
But not in full screen, sir.
Okay. One second.
Now it's.
Okay.
Yes, sir.
Yeah. This is the building, the office building of Suzlon company. So they made one landmark building where they are trying to make it close to the zero carbon footprint. You can see the small turbines on top of each building, the wind turbines, which you see in larger scale. So they are pioneers in building construction. You can see the shade of those wind turbines in the small tank in front of them. Then this is Taj Vivanta by Taj Bangalore. They have made a building using renewable technologies, energy efficient technology, water conservation. We have tried to use sustainable practices, then rainwater harvesting, etc. The next building is the CPT building. CPT is one of the educational university institutions in Ahmedabad. And this is the Infosys campus, Bangalore. Mysore. Okay. They have made this building focusing on sustainability. The campus includes features such as rainwater harvesting, solar power generation, and waste recycling, etc. Then next building is the ITC Green Center in Kolkata, probably, I think. Then the next building, this is the Tata's Consulting Services campus in Chennai, near Chennai, Seri campus they call it. This, they made it environmentally sustainable, green building practices, energy efficient lighting, etc. Then as you must be aware, the Engineers of Science Bangalore, a lot of greeneries and eco-friendly campus. This is a typical project, Cochin International Airport. They have made an airport with a solar park. They are probably powering all the power requirements of the airport from this power plant. Okay, I'll go back to my presentation. So, push these green initiatives. Like you might have heard, our Prime Minister launched one scheme called Mufti PM Suryakar Yojana, Muft Bijli Yojana, where government is giving subsidy on installation of these rooftop solar panels, and they have allocated 75,000 crores to this project. They will give about 60% subsidy for solar systems up to 2 kilowatt, and 40% subsidy to 2 to 3 kilowatt. By spending 75,000 crores per annum, they are approximately likely to save 75,000 crores of energy bills. See the how our wind, solar energy can save money. And slowly, India is focusing more on the non-fossil fuels. Now, I think right now we are having about 50% of our power generated from fossil fuel. And renewable energy, that solar, wind, biopower, or hydro project, all together contributing to about 38%. In terms of megawatt, it is renewable energy now about 192 gigawatts. Our government targeting to increase the capacity of non-fossil fuel to almost double from 190 to, not double, I think more than double, 500 gigawatts by 2030. They are aggressively spending money rather than financing the non-conventional energy projects, so that our dependence on the fossil fuel becomes less and less as we progress into the future. So also the government is investing heavily on the.
Excuse me, sir. Slide is not visible, sir.
No, slide is not slide. I'm just reading out from a few statistics.
Okay.
This is not a slide. I just a small literature which I just explaining how our government of India is trying for green initiatives. And also our government is spending they are spending money on the green hydrogen mission, where we have target to produce 5 million metric tons of hydrogen by 2030. You might have heard this recently. They have run one hydrogen based electric engine, and they are giving good amount of subsidies to electrical vehicles under the scheme FAME, the Fast Adoption and Manufacturing of Hybrid and Electrical Vehicles. They are giving some subsidy to manufacturers so that they can produce the hybrid or electric cars at a competitive prices. So going into the future, we'll be able to see more adoption into environmental friendly, sustainable constructions, and probably maybe our generation is slowly shifting from conventional technologies to environmental friendly, sustainable constructions. So that is the presentation, probably on my topic. This is a very basic, a very novice stage. We are very much in the primitive stage of this planning, sustainability planning aspect. Hopefully, in coming years, we will be able to adopt these technologies more and more.
Thank you, Ramesh Movaji,
Yeah.
for your extensive coverage over all the details. And I think we can ask, we can stop for a while for some question and answer session.
Yeah.
Participants.
Yeah, sure.
Shivani Janak, you can ask the participants to share the questions. Any questions?
Yes, sir.
Participants, you can ask questions.
Yes, sir. Yes. Participants, if you have any questions, please ask.
And one more thing, well, let us welcome Professor Nitin Sonaje sir, the next resource person, already joined the meeting.
Oh, okay,
Welcome,
great.
sir. Welcome, sir. Nitin ji. Is it audible, sir? I think he is in mute. Sir, am I audible, sir? Nitin, sir? Okay, question and answers. Any participants can ask any questions?
We're just in time to complete.
You have still slides are there, Ramesh?
No, Gopi, that's it.
Over. Okay, right.
Okay, they can text me. They can ping me the any.
No. In messages also they can ask.
Yeah. They can pass on, or I can answer.
Yeah,
them.
please.
If
Someone
they can,
already asked some question. What are the next generation construction technologies or methods?
next year construct technologies.
Hmm.
The construction technologies mainly in the we have to adopt the prefabricated construction. That is one of the aspect that can save a lot of effort and a lot of wastage. And we need to redesign our buildings to take care of those things. And I think nowadays the 3D printing technology is coming up.
Yes.
I see there are IIT Chennai built a small building with 3D printing technologies. That's going to save huge amount of cost, it seems. So we don't have much.
But they're not into commercial aspect.
Yeah, that's what. Maybe there's coming. Maybe in future, probably we'll be able to have commercial applications in the technology. Probably.
There are some other questions.
One more question is this, sir. How do you forest climate change impacting long-term water management strategies in urban and industrial context?
As I said, in industrial complexes, we have two systems. The water that is in direct contact with machines, and the one with the indirect contact with the machines. Like, for example, you have in the rolling mills, you will be spraying water onto the hot billets. So that water will be treated much stringent way to remove impurities, and again it will be reused for the purpose of same hot applications. What we do is that about 10%, say for example, you have spent 100 liters of water in, you have sent it to the cooling purpose of the hot billet. That 10%, 100 liters water becomes 90 liters because when you spray water in hot surface, it gets evaporated. So you have 90 liters of water. Then when it goes to the treatment plant and other things, it becomes 80 liters. So what we do is that out of 80 liters, we blow down. They call it blow down. They remove 10 liters of water and add. So that means you have effectively 70 liters of water left. So we will adding 30 liters of fresh water into circuit, and that will be recycled again. That's how we conserve water in industries. In case of indirect cooling water, like where you have heat exchangers or bearings of a turbine or generators, that water is much cleaner. So it doesn't need any blowdowns or things like that. So it will be 95% water will be reclaimed and 5% we keep on adding. But where in case residential buildings comes, probably we are very much what you call technology point of view. As I was discussing the grey water. The grey water is the basically water coming out of your sink, your washrooms, your bathrooms, etc. Those waters can be recycled to be used into a gardening purposes, or probably you may use it for your toilets, etc. For that, you need to have a separate network of pipelines. So it will be a little expensive, but still maybe down the line, like for example, in our apartment complex, what they do is that they have two systems of water management. One, they get water from municipal water that will be used in washrooms, so in bathroom and kitchen. And one more system is there where they extract groundwater, because water is abundantly available in that area. That will be used for your washing purposes. So that way you are conserving the natural water usage. So probably in future we will, residential part of it is very much lagging behind. Industrially they are trying to save because the water volumes are very huge. So that's maybe future technologies will emerge in that line, or construction practices. Okay, but next question, madam.
Sir, my question was actually, how do you foresee the climate change impacting the long-term water management strategies?
How the affects the, see, basically, once you save water, you are trying to save your natural resources. Now you are trying to save your pumping facility. You are trying to save your energy usage in the pumping, your usage of water for various facilities. So these are all very novice in, like I just now right now the technology is not available to predict how we are going to implement it, in particular in residential areas. So maybe coming years we may be able to have some more light into this aspect.
Sir.
Very novice stage. We are in very novice stage of these conservation aspects.
Thank you, sir.
sir.
Okay.
Next question, sir. What
Yeah.
is the future of precast structures with respect to multi-storied building?
Precast structures. Still that is
Future
not
of
become
precast
popular.
structures.
Yeah, this is a very industry. They probably the people are feeling that it may not be safe. That's why probably people are not adopting the technologies of precast structures. It is not finding place in our residential value. It is like maybe if you give some incentive, as I said earlier, if you use the precast structures, maybe government should incentivize on them on the taxes, or maybe they can give some promotional incentives. Then only that people will start using it. But otherwise, we hardly find any precast structures being used in residential part. But industrially, yes. There are huge. They think they now they stopped casting at site. Now everything is precast. Most of the industry like bridges are there, but inside the plant premises, still they are using the cast in situ methods.
Thank you, sir. Next question, sir. What are the specific barriers to implementing the sustainable project management practices in India's next generation construction, particularly concerning the unskilled workforce and lack of monitoring schemes?
Yeah, that's why I was just mentioning earlier also that you need to have some some regulatory mechanism, or you need to have regulatory mechanism where, as I said, once the plan is approved, nobody is bothering to monitor it. Your building is approved by government, municipality, local municipality, or local corporation. So after that, nothing is implemented, nothing is monitored. So you need to have that fear, or we call, okay, if I don't use this one, I will be penalized. So that nothing is there. When it comes labor and things like that, most of the things are being mechanized nowadays. So that component may not be much of criticality.
Thank you, sir. Next question, sir. How can building information modeling support sustainable project management in next generation construction?
Okay, this building information modeling, this will give you a real, or what you call you can foresee the project progress by using those building information models. By using the model, you can find out how far your progress is made with respect to your cost. And probably if you it will keep on balancing between cost and the progress time factor. So if you are lagging behind, so if you simulate that, okay, I'll do this part of the construction very fast, and then by spending some money, and I'll be able to save some time on that one. So then that will simulate the process, and it will give you some result. Okay, yeah, you can spend now this one. No, you don't spend on that new logic. So that way, these models will help you in optimizing your cost and the time frame.
Thank you, sir. Next question, sir. How can long-term environmental impact of net zero building construction be quantified and monitored?
Okay, that aspect. See, that right now we have agencies to certify your building plans or building technologies, like I said, LED or other agencies who they have like ISO certification. So you have a process. Once you are certifying your process with respect to ISA auditors. So they will not see whether you are implementing to the full extent unless they come for next time. So they will come again next time and see what. Okay, they will go through your records, etc., and then they will and they will certify again for the process. So that process of certification of green technologies is very primitive stage. No, we are not at into that how to measure it and how to monitor it. That okay, that means okay, I'm emitting only 20% of my greenhouse gases or zero emission. Those technologies right now, I don't think we have. Probably it may start coming in future.
Thank
It's
you,
all in
sir.
a very primitive stages.
Thank you, sir. Next question, sir. Usually, it is seen that in sustainable project cost get skyrocketing high, like in case of NIOMS, the line project. How can we tackle that and introduce low cost techniques?
Can you please repeat, please? I'm not able to-
Usually, it is seen that
Yeah.
in sustainable project cost get skyrocketing high, like in case of NIOMS, the line project. How can we tackle that and introduce low cost techniques?
Okay, the line project, what you're talking is, it's not to me, it appears that their concept is going in a wrong direction. That's what I understand there, because one of my friend is working in NIOM, Saudi Arabia. So they try to beat a very massive project instead of starting with some pilot project and then see how it works like that. So they are little clueless now how to save the money on that. Right now they are not they're spending money, but on a very conservatively. So that project we don't know how that shapes out. They could have taken a sample project, like instead of say 50 million people or for 5 million people something. They could have started with some say 1 million or 1 lakh people, then try that one, then how it comes out. So maybe they are over ambitious in that project. Right now, I cannot comment on that because we don't have any data on that one.
Thank you, sir. Next question, sir. In what ways can lean construction principle be integrated with project management to reduce resource wastage?
Resource wastage.
Yes, sir.
The wastage of resources, basically we have resources of manpower and your materials. So those things can be controlled only on the field. I don't think we can have any control on that. See if 10 laborers they were there. Because the supervisor will has to assess that, okay, if the 10 labor can make 1 meter wall of say 10 meters in a day. So those norms are to be monitored at site only. We cannot specifically, maybe there are design norms are there, but which will not be practicable in the field. So that is left to the supervisors only. I don't think we have any qualitative plan to measure the wastage of resources.
Sir, one question is this, sir.
Shivani, I think time is up.
Yeah,
Okay,
they can send me the questions. I can write back to them if they were still.
no, one question. Only one question. You can
Only
continue.
one question, sir.
Yes, madam.
What are the risks associated with sustainable construction and how they can be managed?
What are the, pardon me?
What are the risks associated with sustainable construction and
Okay.
how can they be managed?
Yeah, okay. The major risk factor will be high cost of the construction at present. So the risk is, you have to weigh the risk versus the benefits. Like, for example, you take a medicine. It was tested on, say, 100 people and two people get reaction. Similarly, like that, you have to spend some extra, sorry, not the correct example. You have to spend extra money on that new technologies. Obviously, like your 5-star AC versus 2-star AC. They will be using good quality material. They will be using good technology probably. So for that innovation, you need to spend money extra. So there is no, right now it will be definitely costly. That's why I told you in the beginning, our people try to save each rupee on construction. So they will inquire at 4 places, 5 places, then they zero in on one particular shop to buy the material. So because of that mentality, we will not able to use sustainable materials in our near future, unless it is an industrial project. The cost is the very key factor in our, the biggest risk factor.
Thank you, sir. Thank you, sir, for your valuable time and enlightening session. Your insights have enriched our faculty development program out. We truly appreciate your contributions. Thank you so much, sir.
Thank you, madam. Thank you, Gopinath.
Thank you, Ramesh, for your wonderful session. Exactly by 7:30 we closed. Okay. Thank you for your time management, and let us welcome Captain Dr. Nitin P. Sonaje, sir. Are you there, sir? Is it audible to you?
I am very well here.
Yes, sir. Thank you so much, sir.
Good evening, everyone. We are honored to welcome Captain Dr. Nitin P. Sonaje, an accomplished academician, administrator, and decorated army officer. He currently served as a principal of Government Polytechnic and Government College of Engineering, Kolhapur. With over 31 years of diverse experience in the Indian Army academia and educational administration, he holds a PhD in civil engineering, along with multiple postgraduate degrees including MBA, MA in psychology and more. He has published 48 research papers, authors in 5 books, and guided numerous PhD, MTech, and MBA scholars. His area of research, including wastewater treatment, air pollution, and sustainable industrial practices. A recipient of several military honors, including the Special Service Medal. Dr. Sonaje is also a NAC peer team member and AICTE expert. We are privileged to have such a dynamic and inspiring personality with us today. Finally, I request our expert Dr. Nitin P. Sonaje sir, please take over and begin the 10th session of this FDP. Thank you all for your presence and support.
Good evening. Am I audible to all?
Yes, sir.
Okay, thank you.
Yes, sir.
I hope you are not bored because you had already been there from 6, I think from 6. So I will not take much more time, more than 1.5 hours. Don't worry. So next 1.5 hours, I'll be boring you. And you have to bear with me. So putting my experience as a auditor for plastic waste management, that is audit is being conducted by Central Pollution Control Board, and I am one of the authorized auditor of CPCB. So I had conducted few audits. And I'm a civil engineer, having the experience in the various field of civil engineering. I had made the combination of this plastic waste and civil engineering together, and I'll be presenting you
Enter screen.
whatever.
Stop sharing. Share. Share. Enter screen. Enter screen. Share. Yeah.
Once, no?
Yes.
Is this my presentation is visible to you?
Yeah, visible, sir. Visible, sir. You
Yeah.
make it full screen, right?
Yeah.
Sir, two screens are visible, sir. Only
okay.
display first screen. Make it slides. Yes, sir. Make it slideshow, sir. Yes, sir. Yes, sir. Click it.
Yeah. Slide show. क्लोज कर दो. Can you able to see one slide or two slides?
Two slides are coming, sir. I think your presentations, you click the next button, sir. So, top. No. Tab, yeah. Yes, correct, sir. Right, sir.
So as I said, putting my this two experiences together, that is auditor of a plastic waste and a civil engineer. I made this combination of these two, and I'm trying to present few ideas about the plastic which can be used as a construction material. So let us see. We can see the plastic everywhere. In my first this picture, it says how it is being spread as we throw the plastic in the dustbins, and from the dustbin it goes to the dump yard, and from the dump yard, these garbage collectors, they are collecting this garbage as a plastic, and this collected garbages that goes to in one of the place that is recycling industry. Or maybe scrap vendor, and they segregated something like this. After segregation, in the same industry, they make it a compressed one and make this such a type of compressed packing, and they send it for the further processing. When this compressed packaging goes to the industry, that is from raw plastic, they make some granulars. And these are the final granulars. We are getting it from this raw plastic. And these final granulars, they are putting in the gunny bags, and that is finally been disposed for any of the uses. That uses maybe in the construction industry, or maybe making some other products other than construction part. So I'll be showing some videos on this, from this collection process to packaging process, how it comes. These are the industrial videos wherein I had made this audit. So let us see these videos, how it looks like. These videos are from industries. See, this is the garbage collected in the industry. How is the way they are stacking it? This is called air wash. This garbage is in washed with the air. Then after washing, the crushing of this plastic has been carried out. They have made the smaller pieces of the plastic. These are the crushed plastics. From the crushed plastic, it has been melted. See how they melt it. This crushed plastic, they put in the oven. They melt it over here, and this we can say cubes of this plastic. This is plastic ball, and these plastic balls or cube, you can say, they are prepared this raw plastic. They call it a cake, plastic cake. It's not birthday cake. It's very hot. After solidification, it gets cool and it's heavy. After seeing this video, I'll take you to the another one. Now see, these are the gunny bags. They are putting it in this particular machine. They are making it in small pieces. They are washing it so that all dirt can be removed. Okay, coming on to the next one. What are the pieces you have seen in the earlier videos and these cubes? See how the process goes. From that cubes, again, they had made it into smaller pieces. These smaller pieces, this machine is called as the extruder machine. They are making it in the pipe shape over here. And coming on to my last video. So this is the most important one. Now this threaded material, they have sent to the extruder. This is called as extruder. material is heated over here. Then from this end, these are the plastic thin wires, you can see very hot. They had dumped in the water. And now it's cold plastic wires. Here they are cutting it, shredding it, and they are making the granules. So these are the granules coming out. So this is how the entire process of plastic manufacturing from the garbages to final plastic product, which we are generally utilizing for all other our purposes. Even if you can see your this oil pouch, what you brings in the home, that oil pouch is also made in the similar fashion from these granulars.
क्लियरेंस इंटरवल, इसको हम लोग क्या बोलते हैं? क्लियरेंस इंटरवल. अब जब हम सिग्नल पढ़ रहे हैं तो आपने अपनी लाइफ में बहुत अलग अलग तरीके के सिग्नल्स देखे होंगे, ठीक है? जब हम
someone is talking. Okay. Coming on to this background of plastic uses in the construction industry. See, if I take the example of India, in India, as per 2019 census, India generates about 9.4 million tons of plastic waste annually. This 9.4 million tons is at just 3.1% of global plastic waste. So how much we are contributing is 3.1 plastic waste we are contributing. And it is expected that we will be fifth largest generator of the plastic waste in 2025, this year. So when this survey will be made, we'll get to know whether we are fifth or sixth. It's not a proud. I say it's not a proud for us. So out of this 9.4 million tons, we can able to recycle only 60%. And remaining 40% goes as a litters, landfill, and incineration. So we are discussing only on this 60%. If we see per capita generation of this plastic waste, in the Goa, it's the highest. That is 60 grams per day per capita. In Delhi, it is 37 grams per day per capita. And national average is 8 grams per day per capita. It has been observed that 60 major cities, they produces about 26,000 tons of plastic waste per day. 26,000 tons of plastic waste per day. And for this, what is required is from linear plastic economy to circular plastic economy. At the end of my presentation, we will see what is this linear and circular plastic economy. If I come to the global scenario, in the global scenario, use of this plastic waste or plastic combined together, that is about 17 to 25% plastic is used in the construction industries. Out of that, PVC pipes, windows, cable, their share is 40 to 50%. So most of the time, this major construction material is pipes, window, and cables. The polystyrene, EPS, which is used for insulation and lightweight filling, these are 10 to 20%. Polyethylene, that is HDP and LDP. More common names are HDP, high density polyethylene, and low density polyethylene. These are 10 to 25%. It is used for the pipes, membranes, and film making. Polyurethane, which includes polyurethane foams, it is used for thermal acoustic insulation in civil engineering. That is up to 10 to 15%. Polypropylene and others, that other part of plastic is only 5 to 10%. That is geotextile panels and sheets. Yeah. If I say put the current scenario, we have a recycling methods in India, that is mechanical recycling. That just now we have seen some videos. These are called the mechanical recycling. This plastic, again, it is used as a recycled material in the road construction, cement kilns, and waste to energy. Waste to energy is nothing but from the plastic, oils has been extracted from the plastic, and that oil is used for the energy purpose. So major clusters of this plastic industries are based in the Gujarat, that is places called as the Dhoraji and Vapi, in Maharashtra, Mumbai and Solapur, Delhi, and Indore in MP. Various states in the India, they had made some initiative. Kerala made it at reverse vending. Punjab is SPV. Maharashtra and Tamil Nadu, they are basically in the plastic roads. And out of this, the industries, we can say, these 230 industries are reprocessors, that is a formal industries. Informal, there are about more than 1,000 units, wherein 70% PET is recycled. This is what the Indian scenario is. In the Indian scenario, as I said earlier, the plastic in the construction, its use is up to 25% globally. In India, it is about 16%. This PVC, PE, PU that I already told you. If I compare it Indian share and global share, so PVC in India is 40 to 50. Same is global. PE globally 10 to 15. In India, it's 20 to 30. PU and EPS 10 to 15, both in India and global. PP and others 5 to 10. But there is a difference in construction share. Plastic as a construction material, globally it is used as 70 to 25%, but in India it is approximately 16%. So we have a scope to reach to the global average. Now there is something called as a virgin plastic. So what is this virgin plastic? It's not recycled plastic, it's the original one. So virgin plastic is used in the construction industry. That is, the benefit of that is it's a moisture resistance. If proper technology is used, it gives you more strength than your concrete, and it is easy for manufacturing. If I put the common types, that is PVC, PV, and acrylics. So its uses are, as I said earlier, it's a piping and plumbing. Next is PVC flooring, which is easy to clean, non-porous and durable. Nowadays it's in high boom. Electrical component as an insulator, cable jacketing, electrical conduit, switches and outlets. Because this part we are using in the construction industry. Glazing and windows, acrylic and polycarbonate for alternative to glass for windows. So earlier we used to glasses, now we are using it acrylic and polycarbonate instead of glasses. Skylights and protective barriers. We do use this plastic, virgin plastic, for cladding and wall panels due to its lightweight. We also use as a sealant, adhesive and membranes in the construction industry, that is for the watertight seals, barriers and waterproofing. Coming on to the recycled plastic, earlier we had seen is a virgin, now coming on to the recycle. It's a durable, water resistant and eco-friendly, and it is one of the alternative for the traditional product. Coming on to the first use, that is concrete additive. We had seen the shredded plastic in our videos, that shredded plastic or powdered recycled plastics can be replaced with some part of the aggregate, and we use as a concrete additive. If we use the proper proportion, the research says that it's a 15% more durable, and when plastic is used with the gamma radiation, its strength has been increased. That is research says. One of my students has carried out this work, and I also found that it's after adding this plastic with some proportion, it increases the strength. But if you add the more plastic, the strength reduces. Coming on to the road constructions, it is mixed with the bitumen to create more resilience to cracking and water damages. Recycled plastic lumbers. Lumbers is basically for alternative to traditional timbers. Even if you visit any of these monuments or maybe some hotels, you can see from the exterior, it's look like a wooden, but if you closely observe, it's a plastic lumber. It's an insulation that I already covered. A formwork in the shuttering. Instead of using this plywood and steel plates, nowadays it has been changed from plastic, that is used this shuttering material from the recycled polymers, and it is more durable and water resistance. Nowadays in the market, bricks and pavers are coming up. It is compressing waste plastic into durable interlocking bricks or pavers, which diverts plastic from landfills. Roofing tiles, again plastic tiles are coming in the market. That the previous one, that is mud or soil tiles roofing tiles has been replaced with the plastic tiles. Walls and floor tiles and sound barriers. These are some of the recycled plastic uses in the construction industry. So what are the advantages of this? It's a durable and resilience. It's a durable, why? Because less corrosion resistance, no rotting, no pest resistance required. Its weather and impact resistance is very high. It has a long lifespan, cost effective if you take it for the total lifespan of the plastic. Initially, at some cases, cost might be more than the traditional one, but if you use the entire life, then it's cost effective. It reduces labor and transport cost. Coming on to the environment and sustainability benefit, it is resource conservation. It's a waste diversion from landfill to some utilization. Energy saving since transport cost has been reduced, and recyclability. It's a performance enhancing the properties. It's insulation, age of installation, water resistance. It's a versatile and workable. So what are these global challenges of this plastic use in the construction industry? The growth of plastic use is only 9% annually. So it has to be increased. By 2040, 1.3 billion tons of the plastic will be thrown in environment. Globally, 14% plastic is recycled. In India, it is 60%. Globally, it's only 14%. So it is changing the global environment scenario. 500 billion single-use plastic bags are annually used globally. That's the reason Indian government is making this strict compliance on this no use of single-use plastic. They had made the heavy penalty on this, but still we people go in the market and we ask that local vendors, I'm not carrying this my bag, can you give me the plastic carry bag? So he gives us the single-use plastic carry bag, which is less than 120 micron thickness. 91% plastic is not recycled. What are the challenges in India for this plastic used in the construction industry? It's a pure segregation. pure segregation, it leads to the low quality recyclates. And we are not getting the uniform mix of this plastic. Even if I take the example of road construction, we don't get uniform specification of the plastic, uniform characteristics of the plastic. Even we put in the concrete, then it is the same thing we get from the recycled plastic. Yes, if it is a virgin, then the quality we can get little bit good quality, I will say. This plastic is collected through the informal sector, which is unsafe, unrecognized, and underpaid. You can see the roadside garbage collectors, how much he is getting and all these things. The data gaps is a recycling rate, polymer flows, and residues. Let me tell you, friends, when this final product of plastic, that is granulars, which I had shown in the second slide, the rate of sale of these granulars, very best quality granulars, is only up to 40 rupees per kg. And from that granulars, the various plastic material is used, as I gave the example of your oil bag. That oil bag has been made from these granulars. Economics, recycled plastic costlier than virgin. So virgin plastic, of course, it is cheaper than this recycled plastic. So people are trying to get as a virgin plastic. Again, there is a technology gap. Chemical or biological recycling still in the niche area. So with this, what are the issues in India? It's littering and lack of awareness. Because whenever we come across with these plastic carry bags, we just put it in the dustbin and it goes to the some dump pad, and this garbage people, they collect it and so on. It's inadequate infrastructure for recycling. As I had shown some of the industries, how their infrastructure is lacking and how these people are working. That is inadequate infrastructure. Failure to collect waste in slum and narrow lanes. Slum areas, you can find lot of waste is lying over there. And in India, our 40% population is urban population, that is in the slum areas. What that does is, they just throw this waste in the sewages. Informal rag pickers, they are vulnerable. In India, there are 70% are the registered facilitators for this, 20% informal or unorganized, and 10% they recycle at home. So what are the opportunities of this recycled plastic in the construction industry? It's expanded using concrete. Shredded or powered recycled plastic like PET, PEs, PVC as a partial substitute. It's not fully substitute, as what I said. The research says up to 15% we are getting this result. So we have to put a focus on developing standard to ensure the resulting concrete meets structural requirement. Next use is structural elements and composites. Recycled plastic can be blended with other material like fiber glasses to create a stronger load-bearing composite beams, columns, and structural later panels. Now 3D printing is a booming area in the construction. Someone had asked to the previous speaker what are the technologies, and he had also said now 3D printing is the advanced construction technology. And this 3D printing, we can use this recycled plastic pellets as a feedstock. And this is on-site structural component, we can use it. Then improved road pavement. Innovative techniques mix shredder plastics waste with bitumen. Again, proportion. For the proportion, we have to use these techniques. Which type of plastic we are supposed to use in this? That is again the concern for this road pavement. Green infrastructure and landscaping. That is, recycled plastic can be used to produce modular, porous pavers for permeable surface, interlocking bricks for affordable housing, durable materials for retaining walls and coastal protections. This is how we can make the green infrastructure and landscaping. Now, opportunities with enhanced virgin plastics. So earlier we had seen as a recycled, now coming on to the virgin plastic, high performance facets and glazings. As earlier slide I said, these facets and glazing we can use it. That is lightweight facet and roofing materials, modular and prefabricated component, lightweight plastic component such as windows and door. If we can use this, our speed is automatically increases and it reduces on-site labors and cost. Smart building integration, plastic components can be integrated as a smart technologies like sensors and fiber optics. Plastic conduits can be embedded with sensors to monitor structural health or energy uses. And let me tell you, this use has been started in the dams and reservoirs walls. So what are these opportunities to use these plastics? So there is something called as a circular economy initiative. So what is that circular economy? As in the very first slide I said about this circular economy, that is creating robust infrastructure for collecting, sorting, and processing plastic waste, which will increase the supply of recycled material for constructions. The circular economy, it says, it's a recycling again and again, where the losses will be the very minimal. Next is government incentive and policies. So what the government had made the incentive is, if you are recycling this plastic, or if you are giving this, converting this garbages of plastic garbages into granulars, you will be getting some carbon credits. And that carbon credits, you can sell it to the another industry who are making the final products. So whatever the carbon credits you are getting it, the taxes, they are interlinked with the carbon credit. And let me tell you, I being an auditor, we generally see this, how much carbon credit these recycled industries are getting it. Is it really worth or not? And that is government incentive and policy. Emerging recycling technologies. Chemical recycling process, which convert mixed or contaminated plastic waste into high quality feedstock for new construction material. So we have to see the chemical properties in the proper way, so that, as I earlier said, to get the uniform characteristics of this recycled plastic. It's affordable and modular construction. In case of low cost, it's easy for production and recycle plastic bricks and its panels. It's an excellent opportunity for low cost housing, especially in the regions where in the limited resources are available. So if I define it, what is the linear plastic economy and circular plastic economy? In the linear plastic economy, which follows take, make, and dispose. Which follows take, make, and dispose approach, which result depletion of the resources when you take it. When you make it, after making, you use it, and after use you dispose it. That dispose is giving the environment pollution, and that dispose is giving us the large volume of waste. That is called as linear plastic economy. Now coming on to the circular economy. This circular economy, it keeps resources in use for a longer period. It is economic system designed to eliminate waste. It means use these resources as long as possible through reuse, repair, refurbishment, remanufacturing, and recycling. In a circular economy, in simple form, reuse, repair, refurbish, remanufacture, and recycling. That is 5R. 5R is a circular economy. Now this circular economy is gaining a traction as a sustainable alternative because of its reuse and recycle, which minimizes waste and minimizes environmental impact. So we have to look towards this circular economy. So what is shortcoming with this plastic economy? It's a resource depletion. Because every time we require new plastic, we don't reuse it. And when we don't reuse it, it generates massive waste. And when that waste is not being created, so what we do is we do it for the landfill, incineration, or we just throw it in the environment. So it gives the environment pollution. And in the environment pollution, the soil contamination, water supply contamination, toxic gases, greenhouse gases, these are the effect of this environment pollution. Economic inefficiencies, because it's so volatile in the resource prices, because every time we have to take it as a new plastic, and it interruption, most of the time this prices gives the interruption in supply. Now coming on to the circular economy, design a circularity. In the circularity, design modular component that can be disassembled and reused. That is what, as a civil engineer, we have to do it. We have to design this modular component so that they can be in the circulation, which can give the greater flexibility, which can be recycled, which can be repaired. Prioritize reuse recycling. Reusing plastic products such as plastic formwork for the concrete extend the lifespan, and it is more energy efficient than reprocessing. In this case, the initial cost might be more, but if you take the lifespan of this formwork, the cost is again reduced. Utilize advanced recycling technologies. Advanced technologies like chemical recycling, that is pyrolysis, can be breakdown in mix or low quality plastic waste into high quality raw material. Boost waste collection and reprocessing. Nowadays, most of the municipal corporations, they are putting their stress on this waste collection and processing. N number of units are coming up, and we, as a civil engineer or as a mechanical engineer, we are giving this third-party consultancy for this waste collection and its machinery for the waste segregation. Develop innovative applications which can add the values, converting high-performance composite structures, structural elements, and construction materials. We need to put the focus on the innovations and scale up the local solution. That is, producing eco bricks is a local solution, plastic road is a local solution, it can be scaled up through the government policies and private sector investment. In conclusion, if you ask me, as a civil engineer, if we look towards the circular economy, which is gaining traction as a sustainable alternative that reuses, recycles the plastic to minimize the waste and its environmental impact. So with this, if you have any question, I will try and answer it to you up to my possible extent. So now forum is open.
Yes, sir. One question is there.
Yeah.
Sir, what is the quantity of plastic waste in 2025 in India?
In my very first slide only, I said what is this plastic waste, quantity of plastic waste in 2025. We will be the fifth largest generator. At present, it's a 9.4. That time, it is predicted as somewhere around 17 to 20 million tons of plastic waste per year. That is 17 to 20 million tons will be there at the end of 2025.
Next question, sir. How do plastic components integrate with traditional building material in hybrid systems?
Traditional building material, as I said, it can replace your bricks. You can mix it with the concrete. It's a 3D printing material. These are some of the uses. Even our electrification, that is also plastic. Electrical conduits, again plastic.
Thank you, sir. Hello, participants. Next question is there, sir. What is the reason that plastic is not collected properly where we lack? Why people throw it away? What is the lack in government planning?
It's I don't know who had asked this question, but ask the same question to yourself. What do you do once you take this carry bag from the plastic, take the material out in your home, and what do you do for that particular plastic? You just throw it to the dustbin. If anything breaks in your home of a plastic material, you throw it in the dustbin. And where it goes, if you knows it, what processing that does, if you knows it, then I think you will get the answer from yourself only. It's a lack of, I will say, responsibility of the every citizen. We are not responsible. We are making that, why I'm not responsible for this plastic. So municipal corporation will take care of it. So this is the, I think you yourself will get the answer from this.
Thank you, sir. Next question, sir. Will it be beneficial if people in villages or small towns start a plastic recycling units?
Definitely, because I had visited a number of plastic recycling units. So their economy is something like that. The garbage picker, I'll give one example, small example. The garbage picker, he collects the recycling bottles, that is our Bisleri bottles. After collecting a huge bunch of recycling bottles, he gets something about 10 to 20 rupees of that bag, bunch of recycled bottles. That recycled bottles, it goes to the scrap vendors. Scrap vendor, what he does, he just compress it, make it in the smaller volume, and he send it to the recycle industry for crushing purpose. When it crush, after crushing, after making this granular, that industry person is selling it at the rate of up to 40 rupees per kg. And if you see your plastic, plastic bags, most of the plastic bag, they says it's a recycled plastic. We buy it at the rate of ₹15 per kg. And at what rate that recycler person is selling it? At the rate of 40 rupees per kg, and that is also mixed. It is not fine product. But if it is a fine, then rate is about 140 rupees per kg. So if you put this plastic industry in some, say, in the recycling industry in the villages, wherein you will get the plastic at very reasonable cost, raw plastic from the these plastic pickers, then wherein another component is the cheap labors, and third one, the rate of electricity consumption in the not consumption, whatever we consume, we pay for the electricity board. That rate in the villages is lesser than in the cities. So this is the benefit you will get it. And if you make it a small scale industry or MSME registered industry, again, you will get this all government facilities for this. So this is how it will be useful in the rural economy. I hope I had answered it.
Thank you, sir. Next question is that, sir, how does the linear model contribute to global plastic pollution?
It is not it is contributing because we are not recycling in the linear model. We are not reusing it. We are not remanufacturing it. We are not refurbishing it. So if we do it, that is a circular economy. If we don't do it, it is a linear economy. And this is how it enhances the, or I would say it pollutes the global environment. Next.
Thank you, sir. What can be done for the upliftment or rake pickers?
Upliftment. As if now government had not made any policy for the rake pickers. But some of the municipal corporation at their level, they had made this policy basically for health and hygiene, minimum wages, and they are, with this minimum wages, they are protecting these rag pickers with PF and ESI. But it is at the municipal corporation level, not at the state or central level.
Thank you, sir. Next question, sir. What is the difference between linear and circular plastic economics?
I have made it very clear. Reuse, recycle, refurbish, remanufacturing. If it is there, it's a circular. If it is not, it's a linear. In simple terms.
Thank you, sir. Any more questions, participants?
Even participant can raise their hand and you can unmute them. They can directly ask me, no issues. Because if I go for any of the material, it's a vast subject itself. If I make it say use of plastic in the road construction industry, itself is a PhD topic. If I say the use of granulars in a concrete, it itself one thesis. So over here, I had tried to make it a combination of everything and tried to summarize in one presentation.
One question is there, sir. How can private organizations get involved in supporting government for recycling of plastic?
So whatever the videos I had shown it to you, these are all private industries. These are all the private players. They are, because the white collar people, they say it's not our job of recycling. But if you see the economy, if you see the profit, if you see the turnover, most of these industry owners, which industries, which videos I had shown it to, they are, we can say, illiterate or less literate. They only knows how to get the profit. Even at present, what CPCB has started, they had asked these people to put their entire data on the CPCB portal. So how much is the raw material they are consuming it? How much is the fine material they are producing it? And if you see the consumption of raw material in terms of its volume or weight is nearly equal to the production of fine material in volume or in terms of weight. Their waste is less than 0.01%. So there is no waste. These people, they are getting labor in a very cheap rate. And even transportation cost is not much, because in every city you can see this garbage pickers, then scrap vendors. So again, transportation is not much. But when this final product goes to the industries, say suppose take the example of the PVC pipe. See, whatever the granulars they had made it, it goes for the PVC pipe industry. And just imagine what is the rate of PVC pipe you are getting in the market. Once you go to buy this, how much is the rate? So this is what the economic difference is there. तो इसमें जो बोला जाता है, जो poor है, he remains poor. The person who is rich, industrialist, he is getting rich and rich day by day. So choice is yours. In fact, once upon a time while visiting this industry, I had asked these people, how much is the fixed cost of this equipment and all these things. So what I found is fixed cost of all these equipments up to shredding, up to making these granulars, fixed cost is less than around 10 lakh, except your land cost, and that whatever the shared construction cost, you remove that land and shared construction cost, the cost is less than 10 lakh, which you can recover within 6 months. This is what the economy, actual economy is. So if you put in the mind, this is one of the, you can say, startup. With some modified technology, we can make it as a startup. Yeah, next.
Thank you, sir. Next question. Sir, is there any fire safety rating and thermal insulation properties of wall 3D printed with recycled plastic?
That's the reason I said it's a technology based 3D printing. Again, what purpose you are using it, and even if we use it for the acoustic purpose, again our fire safety norms are different. If you are using it for the household purpose, fire safety norms are the different. So it's depend on where you are going to utilize it.
Thank you, sir. Next question is that, can we use plastic to build a complete residential building replacing concrete?
Yes. 3D. Have you seen any video? There is one building in Pune which is made by 3D printing, and 3D printing entire material is plastic. So that is excellent example. On our social medias also you can find out this plastic building is made with the 3D printing.
Thank you, sir. Next question. How can academia influence policy development for sustainable plastic construction?
It's a very good question, and that's the reason EPCB, Central Pollution Control Board, they have started integration of academia in their auditing process. So once I do this audit and all these things, I get to know where are the lacunas. Let me tell you my own example. When one of my MTech student, she was using these plastic granulars in the concrete. That time, first problem I faced, from where to get it. Second problem I faced, what are the characteristics of these plastics. And third problem, it's a durability. But now if you ask me, apart from durability, I got the answer for these two, where to get it and how I can get this quality material. If this recyclers, if they are techno savvy, if they are segregating properly, I had seen one industry, they are segregating these PET bottles in colors. So green color in one basket, red color in another one. So they are segregating like this. And if this segregated plastic, same material, if they suppose Coca-Cola bottle or Pepsi bottle, if all these Coca-Cola or Pepsi bottles are segregated separately, if you use the same material for the making the granulars, so granulars will have the similar characteristics, and similar characteristics we can use for the whatever the purpose we can. So this is how the economy can be enhanced.
Thank you so much, sir.
Yeah.
Any more questions? Thank you, sir. We extend our sincere
And
gratitude.
one more question is there, madam. I can see how the plastic can be used as.
Okay. How plastic can be used for fuel production?
Yeah, it's a very good question. In my earlier college, we had this diploma in plastic engineering, wherein we had this machine where you can extract the oil from plastic. And very latest research, it says some 2,000 some liter, somewhere around 2,000 liters of plastic oil they had generated, but it's not edible oil. It's not edible oil, it's a fuel. This plastic oil is used for the fuel purpose. They had extracted around 2,000 liters per day oil from the plastic. So I had not read the entire paper, but I read these headlines, and then I had asked my head of the plastic department to find it out what machinery they are using it and what machinery my academic people he is using it. Because when we extracted the oil in laboratory, we could able to get about 100 ml of oil from the huge bunch of plastic. This is what my own experience is.
Thank you, sir. We extend our sincere gratitude to you, Captain Dr.
I think whatever the knowledge I have and whatever I can answer, I try to my level best to answer it. Even if you have any queries, you can email it to me. I will put my mail ID in the chat box.
Yes, sir.
So you can mail it to me. I will try and answer for your any further questions, because we all academic people, we have to put our own interest in the plastic recycling to the circular plastic economy. Then only we can reduce the environmental impact of the plastic, and we can sustain. Thank you. Thank you very much for calling me over here. Now over to madam.
Thank you, sir. We extend our sincere gratitude to you, Captain Dr. Nitin P. Sonade, sir, for your insightful and engaging session during our faculty development program. Your expertise, clarity, and thought-provoking ideas have truly enriched our understanding and inspired us to enhance our teaching practices. Thank you for your valuable time and contributions, sir. Thank you so much, sir.
Thank you very much.
1 minute, sir.
Yeah.
Participants, please switch on your video for a quick screenshot. Thank you so much. Thank you for your active participation in the faculty development program. Your engagement and contributions made the session truly enriched and insightful. Thank you, all of you.
Thank you, madam, and I wish you all the best.
Thank you, sir.
Thank you. Bye-bye.
Thank you. Good night, all of you.